Hello everybody, I'm Mr. Loy, your friendly D&T teacher. This short training video is about Unit 14 Electronics, how you actually go about looking for specific answers to the 3-page worksheet. Now this is your second worksheet of the Secondary 3 NA Full HBL D&T lessons. By now you would have completed tutorial 1 and should be in the midst of doing this or completing Unit 14, your second worksheet. And moving on, you will be your knowledge test on basic electronics worksheet, your third worksheet coming up next week's Tuesday's lesson. So just going to show you quickly what you need to have before you actually start tackling this worksheet. Of course, the worksheet itself is 3 pages, and you should have this textbook with you. All right, we call it a reference text because you only refer to relevant topics and we do not go through page by page. And of course, last but not least, your D&T revision guide, which is the brown cover book. Now I'm going to orientate you to the various columns so that you know how you actually should be answering them. On the first page of your Unit 14 Electronics worksheet, you should see the first column, type. These are the names of the specific components given in the pictures. Over here, the second column. So for example, filament bulb, and of course next to it is the picture of a filament bulb with its holder. The third column is actually blank. You are required to draw the circuit symbol with respect to the picture of the component given here. Under the function column, you will have some short phrases, all right, some bulleted points for you to fill up the missing blanks. Take note that each blank does not equate to one word answer. It could be a short phrase. And last but not least, the last column here that states input, process, and output. You are to identify whether that specific component plays its part either at the input end or the output end or in the middle of the process. Okay, so let's see how we actually. Okay, everyone, this is over the shoulder view so that you can see exactly how, as a student yourselves, go about looking for answers when you complete the worksheet here. Okay, so for a start, you must have this worksheet, Unit 14 Electronics. As previously mentioned, all right, these are the various columns that you need to actually familiarize yourself with. I'm going to start slow with filament bulb, the first component here, and as well as the buzzer. Of course, when times permits, all right, you can actually speed up the process and then you answer accordingly. So I'm going to show you how you go about looking for the answers in your D&T revision guide as well as your reference text, which is below. So straight away on page 52 of your revision guide, you can actually identify a similar picture of the filament bulb, right? So down here, you can see the circuit symbol is a circle with a cross and 2 straight lines to represent the wire connections, right? And before I proceed to the next 2 columns, I just want to highlight to you that it's always good to start off with your reference text. Your revision guide, as it sounds, as it means, is for you to actually revise the topics very quickly first, okay, after you have actually done your homework. So I'm going to show you how to use the textbook. So you must turn to the relevant Unit 14, all right, this is on page 259, Basic Electricity and Electronics. So as you browse through and turn the pages, all right, probably the first similar picture you encounter would be this bulb here, right? And of course that is the symbol without the 2 lines. So just take note, without the 2 wire connections here, it is also universally recognized. Okay, now of course, as you would like to actually read ahead, you actually turn, and you should turn, and you find that you actually hit the jackpot, your subtopic 14.10 output components on page 277. This is the almost exact picture of the filament bulb given in your worksheet. Now, of course, here is without the 2 straight lines. So as I mentioned earlier on, both are acceptable. Now, as you read the short little phrase describing what this component can do, you come across filament. Filament here is this part that is in the vacuum glass bulb here, and that element is actually made of tungsten. It actually gives out heat as well as light, which we want as electricity or current passes through it. So if you were to look at the function column, when current flows through the bulb, what you should feel here is either filament or tungsten wire. Alright, so you can actually safely write filament becomes hot, so it glows. The last column is for you to classify or identify whether this component is an output or part of a process or an input device. So obviously the filament bulb gives out light, right? So obviously it's an output. Okay, sometimes in computer terms we just put O/P, I/P for input. Now you will see this feedback given to you for those who have actually completed and uploaded your images via SLS or through WhatsApp. I've actually corrected for you using I/P for input or O/P for output. I pause here for now. Alright students, moving on. The second component here is a picture of a buzzer. If you were to refer to your same page 277 of your reference text, this picture is a bit rectangular in shape, whereas this is circular. So both actually exist in the world. This is the circuit symbol for a buzzer, alright? So you can actually draw it this way or following the suggested direction. Again, it is universally accepted, right? As long as the curved portion of this semicircle is in connection with the two wires here. Now, as a buzzer, it sounds, right? So it makes a sound, okay? Of course, there are other similar descriptive words that you can actually use. For example, a noise, all right? Makes a loud noise, makes a sound, and so on. And of course, since it gives out sound, you hear the sound, all right? So again, it is an output component. Now, very quickly, as you move on, you will see the next item here or component, which is your direct current motor. So if you read the description of your DC motor, which is the symbol here, right? You will find that the direction of turning depends on the way the battery wires are connected. In other words, if you connect a positive here, where the power supply from maybe the battery comes in, let's say your spindle of this motor turns clockwise, all right? Of course, this is your cathode end or your negative terminal end, which goes back to your power supply. Now, if you were to reverse the direction of the current, all right? So this is what it means here. It depends on how the wires are connected. So now, if this left side of the contact is positive, your motor spindle will rotate in the opposite direction. In this case, let's say it's anti-clockwise, and the current will flow back out through the second contact and back to the negative terminal of your power supply. So in other words, let me do a quick sketch. Now this is accepted because it's here. You can also show the two magnets that actually is in contact with the coil of wires that will generate that will make the motor to rotate. So again, this is also acceptable. If you were to shape it, it's also acceptable. All right, so like I said, just a circle with an M to represent motor will be enough. So turning wheels, pulleys, gears, cams, this is what it does. So this is actually at the output end, right? Produces movement, right? Circular movement. Direction of spindle rotation can be reversed by, as I mentioned just now, you just need to switch or swap the contacts, or as I suggested, reversing the contacts, right? Requires a larger current compared to bulbs and buzzers. So I pause for here. As we move on from DC motor to stepper motor, you can see that if you turn the page of your reference text, it's actually over on the next page on 278. So you get a symbol right, draw it here, and you understand the brief description of how the stepper motor works, and you figure out how to fill up the names. Now, fill up the blanks here. All right. Now, in quick, your stepper motor is just like your DC motor is an output device. Solenoid also produces movement, usually at the output end. Now, you will realize that actually there is so-called a pattern as you work through this worksheet. You will find that solenoid is after your stepper motor, all right? And as you turn to page 2, your relay is actually down here. And if you move across, all right, you will see two kinds of diode. One emits light, the other one controls the direction of current flow. So although your LED comes before your semiconductor diode, is on the same page on 279, right? So I'll read the description and the details. So of course, as you proceed, there is a fixed value resistor on the third page. This is the one that jumps a little bit. But if you were to continue on your second page of the worksheet and turn your reference text, let's keep the bipolar transistors for now, and you will find your light dependent resistor on page 288. And of course, after the next page, on page 290 will be your thermistor. Okay, and we continue with your potentiometer over here. Now, you might not be able to find this picture of the variable resistor. I just like to highlight that in short, most of the time, this is actually for more smaller size circuitry, all right, your micro components and microelectronics. For your lower secondary ALP robotics, you would have actually encountered one or two of these micro switches. In this case, it's a variable resistor that you use a tiny little screwdriver to control the sensitivity or the amount of current flow through the variable resistor. So it's used to control the current. Now, I will go through the last column in a short while, but you will find that this potentiometer can also act as a variable resistor when only two of the three contacts are actually used. If all three contacts are used, it becomes a potentiometer which controls the voltage, right? And of course, let's move on. We'll skip the thyristor for now. You will see at the back both your electrolytic or polarized capacitor as well as your non-electrolytic, your non-polarized capacitor details are actually here. All right. If you were to do a Google search, Google image for your circuit symbol for your electrolytic capacitor, you will find a range, a few different circuit symbols. This is the easiest. All right. So follow this one. All right. So if you were to draw something like this, it is not wrong. Okay. And I think in America they actually do this. This is also not wrong, right? As long as you have a plus to indicate the positive end where the current will go into, will pass through the capacitor to create the electric charge. Okay. So of course this is the non-polarized or non-electrolytic capacitor. So current can pass through either ends and charge and discharge through either ends as well. So I pause for here. Now students, as you work through the 3 pages of Unit 14 Electronics worksheet, as you have actually seen in the demonstration just now that each component may have more than one circuit symbol representation, right? The rule of thumb again is go for the easier to draw one, okay? So let me just do a quick go through. So we already gone through the the filament bulb, the buzzer, the DC motor, and we briefly touched on the stepper motor. Stepper motor, as you can see, I chose the simpler circuit symbol to draw. If you were to refer to your textbook or your revision guide, you will see that this one has coils or wires for you to draw. Alright, so this is a little bit more difficult for you to remember, so this is the easier symbol for you to draw. Then, of course, over here, I already run through whether that component is an output or an input or part of the process. So your motors, DC, and your stepper motor, they are both output devices or components. And so is solenoid because it provides a linear motion, all right? When it's activated, it either pushes the plunger out or it retracts the plunger in because inside it there's an electromagnet. And again, there are a few ways of drawing the symbol, so I drew the simpler one, right? So refer to your textbook or your D&T revision guide for the various symbols. Now, of course, it will be good for you to actually know more than one way of circuit symbol representation for each component. As you turn to the second page, all right, you will find that the relay. Now, the relay is actually a middleman between a primary circuit and a secondary circuit. The primary circuit is usually a low voltage sensing circuit that will trigger or allow the relay to actually latch on to a second circuitry that may have a higher voltage output component like a siren, all right? It's not like a tiny little buzzer. So this relay is actually part of the process, or you can consider it as actually the output end of a primary circuit. All right, so if you look at primary and secondary circuits together as one whole circuit, then your relay is part of the process. Okay, if you look from the primary circuit point of view, the trigger could be some sensor, motion sensor, heat sensor, whatever, and it triggers the relay to actually latch on to a secondary circuit. So from the point of view of the primary circuit, your relay is actually considered an output. Okay. So then we move on to the easier component like your light emitting diode, LED, which you are quite familiar with by now. Of course, all these you should actually know roughly how to answer. So LED emits light, is an output device or component. Your diode is part of the process because it controls within the circuitry how the current actually flows inside. And of course, many students actually have this misunderstanding between the two symbols because they are so similar, right? One is without the parallel light rays emitting going out, and this one is without. This is with. Next, we move on to the light dependent resistor, LDR. Of course, it is a light sensing circuit because as long as you hear sensors, it's usually an input component, right? So of course, you can refer to your D&T revision guide and your textbook to answer those portions there. So this is an input component, as well as a thermistor, right? Now, sometimes you draw this symbol with a small little letter T with a little circle there that represents the degrees. So this is a temperature sensing device. So down here, thermistors actually have high or great resistance in low temperature conditions, and when it detects heat or warms up, its resistance actually drops. So it has a inversely proportional relationship between resistance as well as temperature. So this is an input device, okay, or component. Last but not least, as we proceed to the last page, this is your fixed value resistor. So of course, between these two, I would rather choose to draw this. This is easier. And what it does is it limits or restricts the current flow or excessive current from flowing in the circuit to protect usually sensitive devices such as your transistor and so on. It is part of the process, okay, because it limits the amount of current flow, just like your diode, which limits the direction of the current flow. And of course, just now, as mentioned earlier on, the variable resistor. So this is also a variable resistor, but if you use three contacts together, it behaves like a potentiometer, which controls the potential difference across specific points in your circuit. So this one, if you use it as a variable resistor, it actually controls the amount of current flowing through, right? So both potentiometer and variable resistor are actually part of the input, because remember I mentioned as a rule of thumb, where a circuit requires human intervention, all right, to do some control, some switching on and off, that you usually at the input end. Of course, last two are capacitors. I already elaborated quite a bit earlier on. So as you can see, there are various circuit symbols universally recognized, especially for the electrolytic or polarized capacitor, right? And you have to connect it correctly, otherwise it will not work accordingly. So both are actually part of the process as well. So this ends the Unit 14 Electronics. We will be moving on to the third worksheet, Knowledge Test on Basic Electronics, in the next training video. See you soon. Hello everybody, this is Mr. Loy again. Just want to do a final closure on your second worksheet, Unit 14 Electronics. This is just to show you the responses that I've actually written, alright, in the various columns here. So what you can do is this last part, you can actually pause the video and have a good look at my answers. Of course, this Unit 14 Electronics suggested answer would have also been shared with you via WhatsApp. Now, the point to note is that the revised suggested answer for this worksheet, especially the function column, you might find that some things have changed, okay? The wordings may have changed, okay? Maybe a typo error was corrected. Nonetheless, the gist and essential informations you can actually find from the same column, right? So as I mentioned earlier on, you can actually pause and have a look at the 3 pages slowly, all right? If you use some form of a phone, mobile device, tablet, iPad, whatever, you can actually pause, and I believe you can actually zoom in, all right, if you want to have a good look at the answers. So of course, do refer to the suggested answers as well. So this is page 1. Don't forget to write the particulars, all right? Habit number 1, be proactive. And this is page 2. I will show the first 4 components. So you may want to pause and have a look at the suggested answers. And of course, this is the thermistor at the bottom of page 2. Alright, you may pause and have a good look. Next, I show you page 3, the first 4 components as well. So you may want to pause and have a good look at the suggested answers here. And last but not least, your non-electrolytic or non-polarized capacitor. Okay, so that rounds up Unit 14 Electronics worksheet. Bye.